Okay, good afternoon, everybody. How are you doing today? Can you hear me? Just please write in the chat. Okay, thank you. Thank you, Chris. Thank you, Leo. Good, good to hear. Okay, guys. Okay, let's start today class. Uh, as you know, that's the Kettering University moved the classes to the virtual because of some power outage to the classroom and campus. We will have the virtual class today. We have now 17 students. I just want to all of you participate in the classes and be active in the class. First of all, answer these two questions. These are the review for the previous lecture. Also, I will consider those ones as a class participation, guys. Please participate in the class activity. And just when I ask some questions, please write in the chat, and then later I will ask you to submit some questions or so on. Okay, let's start today class. Some of you just might be joining the class. Please answer these two questions. Scan the barcode, answer these two questions. I will start to just give you the answers of these ones in a few minutes. Feel free, if you just have any questions during the lecture, just raise your hand or just unmute your microphone. And also, if you saw some problem for my presentation or my voice or anything else, just let me know. I try to just make a kind of good class today. Okay, I saw that most of you answered the questions. Only 1%. Waiting for your answer. One more minute, and then I will show you the results and start to solve the questions. Okay, now good. For your reference, that's how much you studied, and look, first question, 29% answered correctly. Second question, 38% answered correctly. Okay, guys, please make sure you study previous sessions and also previous lecture. Okay, guys, the final exam is coming soon. Now, for the first question, the relative velocity equation VB with respect to A. If you remember on previous lecture, we started to talk about the general plane motion, and I explained that we can write the equation of the relative velocity equation. This is the relative velocity equation. That's also, we can write this one as a VA plus omega cross product of the RB with respect to A. First, this one is the relative velocity of the B with respect to A. It is correct. Also, I show you for the general plane motion, if you remember. For general plane motion, there is a combination of translational plus rotational motion. If you remember, just for this one, it's a general body. Just first move it, then rotate it. Then, for example, this is A and this is the B point. If you remember, just this goes here, this goes here. This is the play of translational. This is the play of the rotational motion. Now, for the rotational motion, if you refer to the rotation of the rigid body, how we can find the velocity? It is omega cross product of the R. You learned this one. It was part of the question I asked you in the previous lecture. And instead of here, we can write this equation. And then means that this also will be because of due to rotational motion. And also, this is equal to omega cross product of the RB with respect to A. The question A1, the correct answer is D. Now, for the second question, to find this disk is moving with the velocity at a point of 15 foot per second. Omega, it is 2 radian per second. Then we want to find the velocity of the point A, this velocity. To find this one, if I write the equation of the motion, look, the equation of the motion that we can write, for example, velocity of, from the total one just I wrote on the previous kind of page. Velocity of the A equal to velocity of the B equal velocity of the A plus velocity of the B with respect to A. I can write this one as a velocity of the A plus this one. It can write as an omega cross product of the RB with respect to A. Now, here, as you can see, we have point O. This is similar, just instead of the B point, I will just replace with the O. Just replace it with the O. Replace it with the O. That's it. Now, this will be VO equal to VA plus the VO with respect to A, or equal to VA plus omega cross product of the RO with respect to A. Okay, now just we need to write them in terms of the vector form. Okay, guys, in terms of these are the vector form of this one. Now, velocity of the O, it is 15. Which direction? This is X, this is Y direction, perpendicular to the screen, it is Z direction. Outward, this is Z. And also, these are I, J, and K. There are unit vectors along X and the Y and Z. Now, this one, it is along the I direction. Okay? Then, equal to velocity of the A we are looking for, plus omega, the magnitude, it is 2 radian per second. Okay? Now, what is the direction of the omega? Can you write in the chat? What is the direction of the omega? What should I write in here? I, J, K, positive or negative? Can you write it in the chat? What is the direction of omega? K minus K, negative minus K. Other students, please participate. There are 26 students. Minus K, David. Yes, Olivia, minus K, correct. Lorenzo, minus K. Yes, the correct direction of the omega, it is in K, but negative direction. If you curl your forefinger and just your thumb is toward to this plane, means that the K will be negative direction. Means that here, K, the omega will be in K, but negative. Then multiply by the cross product by then RO with respect to A means that we want to just find this. The radius of the RO is this radius is 2. Now, to find this one and write this one, what is the correct direction of the RO with respect to A? What should I write in here? 2. What should I write? I, J, K. What should I write? For the RO with respect to A. Can you write it in the chat? Okay, J minus J minus J. Minus J, Nathan. David minus J. Braden A minus J. Jack minus J. Olivia minus J. Are you sure? Minus J. Let's see. The RO with respect to A, unfortunately, I didn't see any correct answer. Means that A wants to go to the O position. Means that this is the correct direction for the RO with respect to A. Means that this is 2J. Now, to find this one, it's equal to VA plus, just multiply the constant ones, minus 4. Then K cross product of the J. This is cross product. This is non-multiplication. Now, this one, K cross product of the J. Just this will be provided in the exam, but this is how I found. This is IJK and a circle counterclockwise. J by K, it is I, but K by J, it will be minus I, the reverse of this one. This will be minus I, means that this is equal to VA plus 4I. Now, if I simplify this one, 15I equal to VA plus 4I, the velocity of the point A is 11I, or the magnitude of the velocity or speed, it is 11 foot per second. The correct answer for this one, if I'm correct, it is D. Any questions? Any question, guys? Okay. Now, can I move to the next slide? Yes. Okay, Drew. Thank you. Thank you, Josiah. Now, for this question, as you saw, this is D. Both are D. They are the answers. Now, I want to just announce about the final exam, okay? Just reminder to all of you that you know that we will have exam on Thursday, March 26, 10 a.m. And for this exam, please bring your own calculator, okay? And pen, pencil, that's it. I uploaded the equation sheets on the week 11. You can access that one now. Just from 10 days, you know that how to use that one. I will print it. You do not need to print and bring anything in the exam. I will bring it same as exam 1 and exam 2. And final exam will be cumulative, similar format with exam 1 and exam 2. And for example, question 1 is a multiple choice question for the question 2 to 5. Mostly will come after exam 2, mostly, okay? But you need to use some of the kind of equations you know, some of the kind of directions you know, some of the coordinates you know. We will have the review session and that you will see, and also you can be familiar with the questions that comes for the final exam, but similar to them. Might be some of them are just coming or just other ones will come. This is for the final exam. We have 10 days, just we'll work together. If you have any questions, just let me know. And those things, I want to just announce about the final exam. Then, you receive an email from the university regarding the university survey for my class. I want to mention that please, if you're interested to get 2+ points to your final exam, just scan this barcode. This is for your classroom. Whatever you need to do, scan this barcode. Just as you can see, when you complete your survey, take a picture of this survey, similar to this one. That I can see your name. For example, this is just one of my students, Madison. Just do not send me this one, okay, only. Just I want to see the capture and your name in here, that this is what you do for my class. Please upload your screenshot to week 11 final survey. If you upload it, you automatically will get 2 points as you did it for the exam 1, okay? Just I will add this 2 points to your final exam. If you are interested again, or if you are sure that you will get 100. You do not need it. That's okay. But please, also, if you get 100, also please just submit your survey. This is for my class. Also, this is for department to evaluate kind of the teaching of the dynamics and helps the department to follow the progress of students in the class. Okay. Any questions? Any questions? No. Good. Thank you, Josiah. No questions. But we have just if some questions comes to your mind, also we will have classes on Thursday and next Monday. You can ask me any questions. Just feel free and or anytime just send me an email just I can answer your questions. Okay, let's go back to the our lecture. I just uploaded the lecture presentation in week 10. You can access to my presentation, today presentation in the week 10. First, what I will do, I will review previous lecture because it was an important lecture. Some of the content I will review, then we will have a kind of new lecture about the mass moment of the inertia. I just explained a little bit about the mass moment of the inertia in previous lecture. However, we want to solve examples. Also, I want to just develop the equation of the motion for the translational and rotational one. Hopefully, I can solve more examples for today's lecture, and also we will wrap up today's lecture at the end of the class time at 3:25. Okay, we started to talk about kinetic equation of the motion. First, for the translational motion. Some of the examples that you saw in my previous presentation and previous lecture presentation just regarding a kind of cart pushing a refrigerator or the landing gear of the airplane, or these are some of the examples that they have a kind of a rigid body that just rotate or translational motion or both combination of translational and rotational motion. What we will do first, consider this is a rigid body that consists of several external forces, as you can see. These are the external forces, and F1, F2, F3, F4 external forces, such as, for example, this is a car. These external forces are the normal forces, are rear, normal force of front, weight, frictional force. These are the examples of these external forces. And also, you will see here that we apply the weight on the center of the gravity. And also, there is a moment. Sometimes in the car example, there is no moment. However, consider I just apply a moment. This is a type of the external moment. For example, for this case, that's we want to write the equation of the motion. First of all, as you learned it before, for a rigid body that has a translational motion, I explained that for the translational motion, we will use the equation of the motion. You know about the equation of the motion. It's the summation of the force equal to ma, such as this rigid body. Now, this rigid body has a point called center of the mass. G is the center of mass. A translational motion means that this one, for a simple case and basic one, just if you follow the position of the G during the time, for example, in moving on a straight path, this is called a translational motion. Or this G is just moving along a curved path, for example, this one. Also, this one is a type of a curvilinear motion. Now, To write the equation of the motion for this body just moving in a 2D plane, just x and the y direction, we will develop this equation of the motion along x and the y direction. We will find the forces along the x, we will find the forces along the y, and they are equal to mass, the mass of this rigid body. Then instead of this acceleration, if you remember, we just used this one for one particle. Now this one has several particles. Instead of adding and also just finding this one for each particle, we will find the center of the mass. Then we will find the acceleration of center of the mass along the x direction. This is the acceleration of the g along the x direction. Same as this one for the y direction. We can write this one, mass multiplied by acceleration of center of the mass along the y direction. For example, this is mass AGY. These are two equations that we will use for a rigid body that has a translational motion. Okay, you learn it from previous lecture. Just this is nothing new, and just review previous. Now we want to know that how about the body that or rigid body has a rotational motion? What about the rotational motion? What type of equation we should use? To use this one, we will use this equation. As you can see, this is an equation of the motion for a rotational one. Just I will highlight this one. Oh no, this is not. This is only for rotational motion, as you can see. What equation I will use? I will use this equation or this one. This is the general form of this one. These are equal, just these are not two separate equations. These are equal to each other. And then, what are these equations? These equations are the moments about the P. These are the moment equation. What is the moment? Just this is my question from you. If there's a bar, I apply a force F. This has a distance of L from support. The moment at the support will be F multiplied by distance L. Similar to this one. If we find the moments of the forces and the external moments, left hand side, as you can see here, this expression, this is the moment of external forces. This is all external moments. For example, I can apply a kind of only a moment at the tip of this bar or beam. This one, it is the moment of inertial forces. Okay? And this one, I will explain. This is, you know, about this is mass moment of inertia. This is angular acceleration. This term is because of the rotation. This is a type of torque or kind of moment. Now, about this one, look about the moments of the kind of inertia forces. As you can see here, we will draw free body diagram and kinetic diagram for each problem. For free body diagram, we will show the external forces and the moment. That's it for free body diagram. In kinetic diagram, we will show the inertial forces MA on center of the mass. As you can see, there are there are inertial forces along X. It is MAGX. This is inertial force along the Y direction is called MAGY. And also, this one is because of the rotation, is IG alpha. This is kind of rotation. This G point from the point P has a distance. If we just measure it from X, it's X bar, and from the X axis it is Y bar, from the Y axis it is X bar. These two forces, these inertial forces, has a moment. Why? For example, I just open a kind of one slide. Look, for example, just a big one for you. This is the point P. This is the center of the mass. This point P can be any point on the body. For example, for the car, we have center of the mass G. This point P can be on rear tire, front tire, on the kind of front of the car, back of the car. Any point can be this point. Now, this is the inertial one, MAGX, along X. This one has a distance of D just along the Y, and also, for example, just use that previous one for you. This one is the Y bar, and this point also has this distance of X bar from the point P. And also, this is MAGY. Now, question. What is the moment of MAGX about point P? What is it? Can you write in the chat? What is the moment of MAGX about the point P? Just it's okay. Just whatever, just write it. It's okay. You do not need to just exactly what I write on the kind of the slide. It's so difficult to write in the chat. Just if you write it, I can understand. What is the moment of MAGX about the point P? What's the moment? MEGX times Y, IG alpha, okay, other students. I'm just collecting your answer. Please answer this one, thank you. Only 2 students out of 27 students. Other students. Others. What's the moment of the MAGX about point P? Just look, moment, it is force multiplied by distance. Now for this one, the force, it is MAGX. Distance is a vertical distance, perpendicular one. This will be MEGX in the y direction. Now, because this one, for this case, MEGX toward to the right, this is this direction. This should be minus. Why? Look like this. That's you're just applying MEGX on the kind of the cap of the water bottle. You try to close and also just the bottle. Then if MEGX is in minus negative direction, you are opening the bottle. That's the reason, just so you can find the positive or negative one easily. Okay. Then also MAGY also has a moment. What's the moment of this one? It will be MAGY multiplied by X bar. Okay. Now, this is the moment. This is the moment. These are not IG alpha. IG alpha is because of only rotation. If you have a rotation, you have this one. This is something different on this one. This we have because of the translation along X. This we have because of the translation along the Y. And also, if the body rotates too, we have IG alpha. Okay? This is different from the MEGX and MEGY and different from the moment of MEGX. Now, this term is the moments of inertial forces. This term is IG alpha. That's because of the rotation. Then I start to talk about the I, or a mass moment of the inertia. This is mass moment of the inertia I. What is this one? If I want to rotate a body with the torque of T, then this body starting to rotate with the angular acceleration of alpha. We can relate T with alpha using I. This I is called mass moment of the inertia. And the definition for the I is the measure of resistance of a body to the angular acceleration. Similar to this equation, F equal to ma. M is the resistance of a body when we apply a F along the direction of the acceleration. For example, just if I have a pen, for example, with the radius of the 2 centimeter, for example, then I have a kind of cylindrical one with the radius of the 10 centimeter. Same height, for example, h is equal, but different diameters. If I apply same torque on both of them, I can see that this one is much difficult than to rotate than this one. Why? The eye of this cylindrical one is more than the eye of the pen or pencil, for example. Now, this question might be comes to your mind that for different geometries, how we can find the I, or the mass moment of the inertia, how we can calculate. To calculate the I, we will use this integral. This integral is the integral, or it's a mass integral. That's is r squared dm. R is the moment arm that is perpendicular distance from the axis of the arbitrary element dm. This is an element dm. If we're just adding different elements on this rigid body together, they will just have the m, or the integral of the dm will be m. Now this integral, if you calculate it, finding the radius of this one from the axis of the rotation, this is an axis of the rotation. If you find this integral, we can find the mass moment of the inertia for different geometries. For example, for a cubic, for a kind of cylinder, for a cylinder, or anything, just we can find it. Now, what is the unit of the I? the unit of the I, or mass moment of the inertia, you can find it from here. The unit of R, it is meter. This will be meter square. The unit of M will be kilogram, or kilogram meter square for the SI unit. And for a kind of US customary units, it will be slug foot square. This is for the unit of the mass moment of the inertia. Okay. Now, for certain geometries, as you can see here, for a thin circular disk and thin plate, these are the mass moment of the inertia for them. You can find those ones on a kind of appendix of the book. Let me see that. I have it. Yeah. This is the appendix of the Hibbeler's book, for example. As you can see here, for different geometry, if you refer, you can find the mass moment of the inertia for them. As you can see, for a kind of this circular sectors, circular area, rectangular one, or for 3D one as a sphere, cylindrical, cone. For different geometry, these are given. What are they? Now, for example, this is the IXX is the mass moment of the inertia when this disk is rotating about the x-axis. The next one is the mass moment of the inertia if this one is rotating about the y-axis. Similar, this one is the mass moment of the inertia if this one is starting to rotate about the z-axis. As you can see, we can do this one by your pen, for example. You can just rotate this one vertically, or you can rotate based on this axis or this axis. Based on this one, there will be different mass moment of the inertia. For example, about this is the z, based on here, this is x, this is the y direction. If you try to rotate them, they will have different ones. What are they? Depends. For example, for a circular disk, Ix will depend to the mass and radius of the disk. And also for a thin plate, this depends to the dimension of the kind of the thin plate along x and along the y direction. Then, as you can see here, if I just delete those ones, x and the y and z, they are passing through the G, center of the mass. X and the y and z, they are passing through them. However, if I want to rotate this one about the z prime, that is not passing through the G. It is passing through different point that has a distance of r from this point. Okay. Now, how about this one? How about the IZ prime or IZZ prime? Okay. How about this one? How we can find this? To find this one, we will use a theorem called parallel axis theorem. What does it mean? It means that for a body that we know the mass moment of the inertia about z-axis, for example, IZ axis. We know this one. This is passing through the G. Then we want to find the mass moment of the inertia about the z prime that has a distance of the d from the G. Just you can see that these are parallel to each other, but they have a distance of d. Now, to find the IZ prime, this will be equal to IZ, the mass moment of the inertia about the Z, plus the mass of this body multiplied by d square. This equation is called parallel axis equation. These are coming from the parallel axis theorem. Now, for the previous problem that you saw in here, for example, we do not know this one. I just mark this. We are looking for this, for a thin circular distance. We have the IZ, but we are looking for to find the IZ prime. If I use the parallel axis theorem, IZ prime equal to IZ plus mass of this multiplied by the distance of Z and Z prime. Now, IZ, it is 1 over 2 m squared, mr squared, plus m, the distance of the G and G prime, as you can see, will be the radius of the this thin disk. It is mr squared. Just instead of the D, I just plug the R. Now, if you calculate this one, it will be 3 over 2 m r squared. Now, just let's see that this is correct or not. If I just check it here, I use the parallel axis theorem. That's this, using this equation, find the mass moment of the inertia about the Z prime. And I can find this one. Okay? Any questions? Any question, guys? Any questions? No? Okay. I'm confused about how you get from 1 over 2 to the... Okay. Look, just this is step by step. Just IZ, it is 1 over 2 mr squared. This is plus m. I just, instead of the D, just I put r squared. Now this one, it is equal to 1 over 2, just let me calculate. This is mr squared is common between these two expressions. From first one, it is 1 over 2. From second one, it is 1 plus 1. This will be 3 over 2. Or this will be 3 over 2 mr squared. Did you get your answer, Josiah? Okay, sounds great. Thank you. Good. Feel free to ask any question, guys. I'm happy to answer to your all questions. Now, example. There's a pendulum consists of this slender rod. It has a mass of the 3 kilogram. Just I call mr 3 kilogram. This is a rod. Also, one plate it is attached to the rod. This one has a mass of the plate 5 kilogram. Then first, we want to find the kind of center of the mass for this 2-1. Then we will want to find the mass moment of the inertia about the axis perpendicular to the page. Look, if this is x and this is the y direction, we are looking for to find the mass moment of the inertia about the z that is perpendicular to this plane. Look, for this one that we will find later about this axis just coming out of the screen. Okay, we want to find the mass moment of the inertia about this axis for this 2-1. I will show you how we can find it. Let's just, if you want to write 1 or 2 minutes, just write it. Then I will start to solve. Okay, now let's start to solve this problem. First, we want to find this mass, kind of the location of center of the mass for this plate and standard rod. Now, first, to find this one, if you remember, might be just use this similar to this one here, static, in MECH-310 course. To find the y bar will be summation of the y bar m, or this divided by summation of the m. Okay, this is how we can find the mass moment of the inertia. Means that I need to just find this, the mass moment at the center of the mass for the plate, for the bar, for the rod. Then for this one, for the plate, then we can find the y bar. How I can write this one? I can write this one as a y bar of the rod, m of the rod, plus y bar of the plate, m of the plate, divided by m of the rod plus m of the plate. Now, first question, what is the y bar of the rod? For example, this is the rod. We want to measure this one from the top point O, from the pin point. What is this one? How much is y bar R for the plate, for the rod? Please write in the chat. Let's see, that's, I want to allow you participate. Everybody, can you write this one here? What's the y bar of the rod and y bar of the plate? First one for the rod, second one is for the plate. Can you please all people write in here? Let me see. I am tracking you, just please, all guys. Other students, 9 people are just participating. Other ones, I'm looking for your answers. Please participate in the class. What is the y bar of the rod and what is the y bar of the plate? Okay, Josiah, can you write it in the chat? In the just the question bar, just sure. Thank you for your participation. Other students, please. Okay. Nathan 0.25 for the plate. Okay. Just for your reference, just measure it from the top point. If you just want to check it from the bottom one, just you need to just make sure for both plate and rod, make sure you measure it from same places. Okay, good. Yeah, just 0.75 for the rods, 0.25 from the plate. Okay. Okay. Bryden, thank you, David. Thank you, Bryden. It's okay, just meter, whatever, just write it here. That's okay. Thank you. Jack, 0.75 for the plate. Good. Okay, Olivia, thank you. Okay, 0.25 for the plate. Yes, good. Yes, let me just show you. As most of you answered this one correctly, just you measure from the bottom, whatever I just found from here. Yes, if we measure from bottom one, for the plate will be 0.25, as you saw. For the rod, this distance will be 0.75. It's correct for all of you. But I measured from top point, from O. It's okay, both just measure from the O or from the bottom one, you will get similar answer. Okay. Now from the O point, as I mentioned, here, Y bar for the rod for my place here is 0. Sorry. Let me see. Some of you answered this one incorrectly. Sorry. This, this is 1. Okay. For some of your answers, you mentioned it. This should be from the bottom of this one, should be 1.5, not 0.75. Okay. From the bottom one, this point will be half of this bar, 1. From this here, 1. Also, just from the bottom one, we will consider this will be 1.5 if we just consider from the bottom line. From top point, this Y bar of the R will be 1. Just let me delete this one to confuse you. And the Y bar for the plate will be here, that from the top one, it will be 2 plus 0.25, or Y bar of the plate will be 2.25 meter from top one. Now, if I write this one again, Y bar of the R, it is 1 multiplied by 3 plus this one, it is 2.25 multiply the mass of this one, 5, divided by 3 plus 5. If you calculate this one, I have this number. If you calculate this one, it is 1.781 meter. This is the Y bar of the R that I'm looking for. First step. Then, next step, let me just capture this one, bring to the next slide. Now, whatever you have here, also, these will be given to you for the exam. Okay. Now, we have rod. This is given to you. We have the tin plate or this one. It is given to you, these equations. Now, what I need to do, I need to find the mass moment of the inertia about this point G that I found it. It is 1.781 from top. Now, you will see that this point, it is different from the mass moment of the inertia for the rod and for the center of the mass for the rod and center of the mass for the plate. This is the reason we need to use the parallel axis theorem. Why? This point is different from the mass moment of the mass center of the plate and the rod. To find this one, we will write the parallel axis theorem. What is that one? It is the mass moment of the inertia for center of the mass for each of them plus m, the mass of them, multiplied by their distance. What does mean this one mean? I will write this one. I will write this one. Ig plus md square for the rod. Also, I will write this one for the plate. Both, they are different, just as you can see here. Their point are different. Now, if you just imagine this one, I want to rotate this one about this point. However, the mass moment of the inertia of this one is different from mass moment of the inertia about this one. Then we want to find their distance. Now, first for the rod, this one, for rod. Ig, the mass moment of the inertia for the rod, plus m dr of the rod square. This is the dr. This is the distance of them. Now, this is the dr for the rod. The mass moment of the inertia for the rod, as you can see here, for here, just it is given based on x, means that x is just coincidence with the z direction we are looking for. This is the mass moment of the inertia that we are looking for. 1 over 12 m L square. Do not confuse with this one, just or this one. This is another one. This is the mass moment of the inertia plus m dr square. Now 1 over 12, just here is the m of the rod. It is 3. The length of the rod, as you can see here, is 2 meters plus m of this one, it is 3. dr, the distance of this to 1. Now, can somebody tell me how much is the distance, dr? The distance between the gr and g. How much is their distance? Can you write in the chat? Zero point 71781. Okay. Other students. How much is their distance? This one is 1.781. This distance is 1. Now we want to find this distance. Look, here is 1.781. This one is 1. We are looking for to find this distance. How much is it? Okay, 0.781. Yes, it's correct. It is 0.781 square. This is for this one. Then for plate, it is the IG, center of the mass of the plate, plus M of the plate multiplied by D of the plate from center of the mass. The D of the plate, if I want to show you here, this is the D of the plate. This is the difference between here and here. Now, the IG of the plate, as you can see, it is about the Z axis. Just it is moving about the Z. Just if you rotate this one, just is about this. It will be 1/12 M A square plus B square plus MP mass of plate by the distance of the G from the G of the P. Now this, it is equal to 1/12 the mass of the plate 5. A, here we have the A 0.5 square plus 1 square, these are the lengths and the widths of the plate, plus the mass of the plate 5, their distance. What is their distance? We have this one is 2.25. Also, we have this distance that is 1.781. Now, their distance will be 2.25 minus 1.781 squared. Now, let's calculate them together. For this one, it is 3 multiplied by 0.781 square plus this will be 1/12 multiplied 3 by 4. This is plus 1. This will be 2.83. And what is the unit of this one? It is kilogram meter square. How about this one? This will be 2.25 multiplied minus 1.781. This one, square of this one equal to 2.25 minus 1.781 equal to the square of this one multiplied by 5. This is this plus parenthesis 5 multiplied by again just 0.5 square plus 1 square. This one is just this. Also, this multiplied by 1 divided by 12. This is this. This is this. Then this one is 1.62 kilogram meter square plus 2 point, just like adding them together, plus 2.83, 2.83 plus 1.62. This will be 4.45. Means that IG, the adding of this one's 2.83 plus 1.62 it is 4.45 kilogram meter square. This is the answer. Okay. Any questions? No question? Okay. If you do not have questions, just my screen sharing. Let's have 5 minutes break, then come back with fresh mind and for the second part of the class. Okay, let's resume the second part of the class. Any questions from first part? No questions? Okay. Now, what I want to do here, what we're learning here, and I explain it. This is the equation of the motion, equation of the rotational motion. This one either are equal to each other. Just if I just want to show you here, this equation. This one, as you can see here, these are equal. This means that this one. This means this one. Okay. Now, what is this? It's the summation of the moment of external forces and moments this is the moment of inertial forces. Now, about what point? About point P. This P can be any points. Okay. For example, for the car example, if you show the forces on the car, G, this is the weight, this is normal force of the front, normal force of the rear, frictional force of the rear, and frictional force of the front. Now, this point P can be any point. It can be G, it can be front tire and just surface of the contact between the front tire and ground, or rear one, or any other points here, here, at any points. This point can be any point. Okay. Now, just delete this. If the point P coincides with the mass center of the G, for this example, if the point P coincides, means that just instead of the P, we find the moment of all forces about the point G. Okay. Now, if we find the moments of inertial forces, for example, for this example, if I just draw the kinetic forces, example for this car is MAG X along X. This is MAG Y. This is the center of the mass. Now, can somebody tell me that how much will be this term if we find the moment of MAGX and MAGY about center of the mass? How much is this expression? Can somebody tell me? Please write in the chat. How much is the moment of MAGX and MAGY about the G? How much is it? Nobody knows? Let me help you. This is a general body, okay? This is the center of the mass. If I have this force, MA, passing through the G, how much is the moment of the MA about the point G? How much is it? Can somebody tell me? 0. Yes, it is 0, guys. It is passing through the G. The distance of this force about the point G is 0. Distance is 0. This term will be 0. Means that for this one also, if I consider that this one, all the points passing through the G, this term will be 0. What I can write this one, this left hand side is summation of the M moments about the G equal to, this term is 0 plus the only term we have, it is IG alpha. That's the point. Now, this is exactly this. Now, what I want to mention that summation of the moment about the center of the mass due to all external forces, it is equal to moment of the inertia about the G multiplied by angular acceleration. This is the kind of explanation for this equation. Now, we have 3 equations for general plane of the motion for the rigid body. What are the equation of the motion? For the equation of the motion for this one, as you learn it. Summation of the forces along the x equal to m ag along x. Summation of the forces along the y equal to m ag along the y. Then summation of the moments about the g equal to ig alpha. These are three equations for general plane motion. This is because of the translation. This is because of the rotation. This can be used for general plane motion. Now, also, I can just summarize and also make those ones simplify those equations. How? For example, for a translational motion, these are the equations that we have. Sigma f equal magx, sigma fy equal to magy, and also summation of the moment about the g equal to ig alpha. Now, for the translation, we know that this one doesn't rotate, alpha will be 0. Angular acceleration. For translation, there is no rotation. Now, if this one is 0, this will be 0. This is the reason. Summation of the moment about the g will be equal to 0. As you can see from here. Now, also, if you want to use another coordinate system, for previous ones, we just used the for example, the translation about the kind of a rectilinear transition, the car just moving along a straight path. How about that the car just moving along a curved path, as I solved this problem for considering the car as a particle? How about this one just moving along a curved path? To use this one, we will use a tangential and normal coordinate system. Then we can write the equation of the motion instead of the xy coordinate system. We can use them in normal and tangential coordinate system. Okay, this is how we can find and also use it for the equation of the motion, for example, for curvilinear motion in normal and tangential coordinate system. Now, what is the procedure for the analysis? First, you need to establish what type of coordinate you want to select. This is an important one. And where is the mass center of the kind of body? Then draw the free body diagram and kinetic diagram. Okay, this. Next step is to identify the unknown. What are the unknowns? For example, normal force, acceleration, for example, apply force, FP, whatever. What is the unknown? You are looking for velocity to find. You are looking for to find the time. These might be the unknown for the problem. Now, three equation of the motion along x and along a normal. If you selected the xy coordinate system, you need to use these equations. If you want to find about the g, this one is equal to 0. If you want to find about any other points, just and also use the normal and tangential coordinate system, you need to use these equations. Also, make sure you consider the frictional force in opposite direction of the motion. Okay, this is the procedure. Now, I want to show you this one on different examples. Okay, now first one. There's a total weight of the go-kart and the driver is 1068 Newton. The location of the combined center of the mass, it is in here, as you can see here. The rear drive wheels together exerts a force of 106.7 on the track. We neglect the horizontal force exerts on the front wheels. What I'm looking for, to find the acceleration of the go-kart and what are the normal forces applied to the tires and A and the B at front and the rear tires. As you know, those go-kart ones, if you're just part of the catering competition teams and you just design those ones and you want to see how this ones work at different acceleration, what type of normal forces apply, then based on this normal forces you will design, simulate the forces applied to the structure. This is how you can apply, for example. Then I will give you 1 to 2 minutes just if you want to read, write, then I will start to solve this problem for you. Okay, let's start to solve this problem. The total weight of the go-kart and driver is 1068 Newton. If I use this diagram to show the free body diagram and use this diagram to show the kinetic diagram. Now, for this go-kart, there is a weight of the 1068 Newton. The rear drive will exerts a kind of the force of the 106.7 Newton. There is no force, horizontal force on the front wheels. This is 0. Also, we want to find the acceleration of the car and the normal force at the front and at the rear tires. If I draw this one, there is a one normal force A, one normal force B at the front and the rear tires. This is the free body diagram for this. Also, for the kinetic diagram, just general one, I will just use M, A, G, the acceleration of center of this one along the X. Then there is M, A, G along the Y direction. Also, I will draw this another one in the red color. I will write Ig alpha. It's because of the rotation. Okay. Now, this is the general one for kinetic. Now, can somebody tell me that how much is the acceleration of the center of the mass about the G, about the Y direction? Can you write in the chat? Can you write it here? What is the acceleration of center of the mass about the G along the y direction? Okay, Drew. Thank you. I want to see who are just in the class and just participated. Who are not, I just want to see. Can you write in the chat? And can you write the question I share? Zero. Yes. Yes, Felicity. Yes, Leo. Thank you. Yes, it is correct. This one, it is zero. Also, there is no rotation. I just write this one in general case. You will see that how you just write. If there is some rotation, we have to consider Ig alpha. For example, for a case of it only tire, okay, a tire can rotate simultaneously when just moving in this direction or there is a slip. For the tire, we have Ig alpha. For only tire. But for this case, there's no rotation. This will be Ig alpha will be zero. Now, we have this kinetic diagram. We have the free body diagram. And please, all of you just pay attention because at the end of this example, I will ask you to just solve this problem for another condition, okay? And I will ask you to submit it in the Blackboard for me, okay? That's what I want to do. Please just focus, and if you have any question, just let me know that I can answer your questions. Now, first for this problem, summation of the forces along the x equal to magx. The forces that along the x, there is only one force, 106.7 equal the mass. We have the weight, 1068 divided by 9.81 multiplied by acceleration along the x. From this one, you can find the acceleration of the g about the x direction. If you calculate this one. Now, acceleration about the g, about the x, it is 0.981 meter per second square. This is the first equation. For the second equation, summation of the forces along the y equal to mass, acceleration about the g along the y direction. Now, what forces we have along the y? We have this force, and then weight downward. Normal force of the A plus normal force of the B minus weight equal to, because this one is 0, equal to 0. Now from this, normal force of the A plus normal force of the B equal to weight. Or this one is equal to 1068 Newton. This is one equation. However, you can see on this equation, there are two unknown, this one and this one. It's an unknown one. Then we need one more equation. What is the equation? Look, guys, I just copy and paste in here for you. This equation. I just going to the next one here. This equation. Either of this one. I can write this one. Summation of the moment about any point. For example, I will find the moment about the point A. Okay? Instead of P, I just find this one about point A. Summation of the moment about the point A equal to summation of the moment of inertial forces about the point A. This is what I have to do for the next one. Now, for this one, just I copy, paste it on this. I use summation of the moment about the A point equal to summation of the moment of inertial forces about the A. For this one, I will look to the free body diagram. For this one, I will look to the kinetic diagram. What I do first, just I make this one into two parts. Summation of the moment about the A. I want to find. What I do, I make a table, look like this. There's a force and their moment about A. Forces we have, just I need to look at here. Do not look at here. Just this. Forces we have. We have normal force of the B, normal force of the A, 106.7, and also the weight. Now, the moment of the normal force of the B about the point A, it is normal force of the B and then this distance, 1524 divided by 1000. Just I want to convert to the meter. Then, what is the moment of normal force of the A? What is the moment of normal force of the A about the A?
0.
0, correct. That's correct. It is 0. What is the moment of this force? 106.7. That's one about the point A. How much is it? Correct, Lorenzo. It is correct, 0.2. Because all passing through this point. You will see that by selecting the point A, what I can do a kind of smart thing to solve this problem. Why? By selecting the point A, I will eliminate one of my unknown. Because already you will see in here, there's no NA. Okay, now, what's the point? Just the moment of the weight. Weight, it is 1068 multiplied by this distance. Sorry. Multiplied by this distance, that is 406.4. 406.4 divided by 1000, and this is negative. The moment it is negative. Why? Just if you can see here, just I'm closing the cap, look like this. It is negative. Now I add them together, summation of the moment about the A, it is normal force of the B multiplied by 1.524. I just convert this one to the meter. Also, minus 1068 multiplied by 0.4064. This is the left-hand side, check mark. Right-hand side, summation of the moment of inertial forces. Same. I want to find this one. How? Make a table, look like this. Now, inertial force. Then we want to find their moment about A. What I have, just look, this is general one. MAGX, MAGY, IG alpha. These are what I have on the inertial force. Just look on this one. Do not look at other free body diagram. Now for this problem, this is 0. Also, there's no rotation. This is 0. This is 0. For this one, MAGX here just has a distance of vertical distance of 381 meter from the A. This will be M. We have the mass of this one. It is 1068 divided by 9.81. This is the mass. AGX, we found it, 0.981. Then the distance, vertical distance, it is 0.381. Now, here, if I just write this one in another color, summation of the moment of the inertial forces about the A will be equal to this one. We will calculate this. It is 1068 multiplied by 0.981 divided by 9.81 multiplied by 0.381. If we calculate this one, the total of this one will be 4690.8. This is the moment of this force. Just this is the moment. Now, moment also is Newton meter. Then I will equal this one with this one. If I equal this with this, you can find the normal force of the B. I want to just write the normal force of the B. If you calculate it, let me calculate on the slide here. The normal force of the B will be 810 Newton, and this is the normal force of the B. Then I will put into this equation that we had normal force of the A equal plus normal force of the B, 1068. Then normal force of the A will be 1068 minus 810. If we calculate this one, normal force will be 258 Newton. Okay. Now, what I want to do, just any questions? If you want to write it here, just you can write it then. Any question, guys? No questions? I think you calculated the kinetic moment right. Where, Josiah? This one. Thank you. Let me check it. Okay, yes. Let me check it. Thank you, Josiah. 1068. Yes, right. Yes. Thank you. You're correct. Thank Thank you. When I wanted to divide, just instead of 0.381, might be I just put 381, not this one. This will be 40.6908 Newton. Thank you. Thank you, Olivia. Hey, guys. Now, you learn on this example how to solve a problem for a general kind of this type of motion, how to write the equation of the motion along x, along the y, how to write the equation of the motion, as I mentioned in here. Then, what I want to do just before I want to give you a kind of class participation problem, one thing I announce, then I will start. I want to announce about the quiz. I just put this one quiz in my syllabus that we will have 3 quizzes in my course. One of the quizzes, if you remember, it was canceled because we had an online class because of the weather condition. Now, instead of that quiz, I want to take another quiz because we already want to have 3 quizzes in my class. On Thursday, at the end of the class time, we will have a quiz, and this is the quiz I want to announce. What I will give you on next session, I will solve more examples. Okay, I will solve this example, other examples, this, and I will give you similar examples, just similar to this one, to find and use the equation of the motion along x and the y, and similar to this problem I will give you for the quiz. Make sure you prepare yourself. Also, I will put some extra problems for you today to solve it, and also you have homework, as I just posted on previous week. Already you know about 2 questions. The remaining is regarding this one that you can solve. Please practice it. We will have the quiz on the next session. Now, what I want to do, look, I solved this problem for you. I will share my screen again, the problem. I solved the problem, summation of the moment about the point A, and I solved this problem. Now, what I want you to do, find the moments about the center of the mass. Instead of A, just put G. And use this one about the G. Calculate this one again about the center of the mass. Then write it on your kind of paper, whatever, just write. Then upload. This is the class participation because I want to see who participated in the class or not. Upload your answer until, this is a simple one, until 3:30 p.m. today. In week 10, I will create this one here. If you do not participate, I think that you are absent in my class. As I can see, some of the students do not participate. Some of them just open this one and then they are not present. Please participate this one in the class, and I will create this one. This is the problem that I have. Okay, just in front of you. Just I will make this one in front of you and find the moments about the G, this point. Whatever I did it here, summation of the moment about the G is summation of the inertial forces about the G. That's it. Do it, write on your paper, submit it in the Blackboard. I will create it on the Blackboard now in the week 11, week 10. Let me just create it. Class participation online. Just find the moment equation about center of mass. The due date will be today. You can complete this one until 5 minutes. Just it's an easy one. I will put this one 3:30 p.m. This is 100. This will be closed 3:30, and that's it. You will see here, just I put it in the week 10 class participation in online. Find the moment equation about center of the mass and just upload it in the week 10. That's it. Thank you for attending the online class. Hopefully I can see you. I'm here for any time you wanted, but if you just solve it, take a picture, upload it in the Blackboard, and you can go. point G. That's it. Got it? No, this one is not the same as this one because we changed the point. Now instead of the A, we just move this one about this one. Look here for your reference for this problem. Just I make this one, bring it here. Look, this is, sorry, this is MAGX, okay? Now, for this point, for previous one, we found the moment about this. The moment will be this multiplied by this distance. It is, what I solve, it is MAGX multiplied by this vertical distance, 381 divided by 1000. However, this is about the A. About the G, it will be MAGX, but because this one is passing through the G, you can see passing through, the distance will be 0. It is 0. Okay, I'm just happy that you got it. Other questions? Everybody, I'm here. Just please make sure you upload. You have 3 minutes until 3:30. For the first one, when you take the sum, it is much. Okay, for the first part, when they take the sum, is it multiplying them together? No, just take the sum, adding them together. For example, for the first one, it is M1. For the first two, it is M2. For the first three, it is M3. For summation of the moment about any point, I will add M1 plus M2 plus M3. Good. add it back to the Blackboard. I couldn't upload. Okay, let me see. Just please wait. Let me see, Josiah. I will extend this one to 40. Just can you just okay? Can you just refresh your page? It is accessible now. Okay. When you upload it, just let me know that I can close it. I can extend it this one to the. Okay, thank you. You have 9 more minutes. All set. Thank you. You're welcome, Josiah. See you on next class. Thank you, everybody.